So let's see a bit about warehouse. I'll type out here on the Excel file. So what exactly is a warehouse? You have got maybe databases, a lot many databases. Let's say one of the databases at India, and other is out there in Europe, and third is in US. Now you need to get the data from all the locations and maybe make a summary report. Maybe at some of the locations the databases are also there. What you need is basically you need to have some kind of summarized database which contains the data from all the locations, all these 3 locations. Okay. But then it comes another database for you. How do you differentiate warehouse database and this database? One is basically point I said, that is it contains the data from many locations. Second is basically users should be able to make use of this particular database for creating the reports which should come on the fly, which should be generated on the fly. When we say on the fly means take as much time as possible. For example, you just drag a field. I want to see the data for 2007. I want to see for India. I want to see for Pune location. Okay, and then at that time itself, the data should be come out. Okay, but how will it come out? Basically, what happens is you have data like this. It contains not many joins, but when the number of joins are there and the data size increases, it will take longer time. So what is required in this particular summarized database is this should be in denormalized form. Yeah. Number 2 is denormalized. One is summary. Collection of data from many locations. Okay, so these are two things out here, denormalized and this one, and usually it is updated on periodic basis, but does not contain immediate data. That is, for example, because as you rightly said, your synchronization happens maybe on daily basis at end of day. But for example, if a transaction has taken place today at 3 o'clock, it won't be available until it is synced. Yes. Okay. Now, let's come here. So this is multi-dimensional concept. Our data warehouse, it's again relational database, center storage for enterprise reporting, and source data comes from production OLAP databases. And loaded by ETL tool. What is the ETL tool is? ETL tool stands for extraction, transformation and loading. You get the data, you transform the data. Transform means basically do some computations, aggregations, or change the data types, do the summarizations, these kind of things, then finally send it to the warehouse. Now there are two kind of schemas out here when we talk about data warehouse. One is star schema. And now there are two kind of tables out here. Kind of tables in warehouse.
I was just asking about have we started the recording?
Yes. Yeah. Number 1 is kind of tables in warehouse are basically dimension tables, Number 2, fact tables. Dimensions stand for basically, for example, the ones which do not contain the numeric data. For example, let's say the fact table is like this one. Let me take this one, sales. Okay, in sales, and in terms of dimensions, we'll have like geography corresponding to this geography, and what else can be there? Employees, customers, and region or geography may be the same basically. So these are kind of things. So it means that based on these dimensions, what are the sales rate? Dimension table store the business context data like product, customers, date, etc. These do not contain any of the factual information. So corresponding to this product, this customer, what has been the sales? So sales will also always be a fact table. Okay. Then the other one is basically one is star schema, fact table in the center of star and dimension tables on the edges. Then the other one is Snowflake schema. What does this Snowflake schema mean? Any idea? For example, this is a kind of Snowflake schema. Here, let me increase the size a bit. Now, if you see out here, you've got a dimension table out here. And large dimension tables are normalized into multiple tables grouped together to form less number of tables. Okay. For example, let's say you got, let me draw it. Okay, maybe draw it here only. Okay, you have got customer, and here you have sales. And here you may also have geography table. Do we have some kind of lines? Search.
Some shapes.
Yes, shapes.
Shapes on the top.
Yes, there it is. So these two are related, and then you have customer and this one sales also related. So dimension, so this is customer is dimension, this is also dimension. Now this fact is related with customer, and customer also has this one. So this is called a Snowflake schema. These are kind of flakes, you can say.
Basically it's like chain, right?
Yes. So instead of having everything out here, because what may happen is you have employee here. Instead of having the duplicate information at multiple locations, make sense? So these are kind of two schemas out here. Now Should we go for Snowflake schema or star schema?
Mixed.
So most of the times it will be
Stars.
most of the times you'll find that it is Snowflake schema. So basically here in the advantage in Snowflake schema is no redundancy. So because if you see out here the example we saw, geography we have moved from here to here. Basically it does not it might have some geography ID only.
Yeah.
Okay.
It's the same. Yeah.
Okay, it has got the redundant data and less easy and hence less easy to maintain or change. More complex queries, hence less easy to understand. Star has lower query complexity, but when it comes to performance, more foreign keys and hence longer query execution time. And here it will be less foreign keys. Okay, dimension tables are normalized, but fact table is denormalized. Where to use when the dimension table is relatively big in size. Then Snowflake schema is better as it reduces the space.
Query performance, I have doubt.
Which one?
Query performance.
Both are slower.
Both are longer query execution, that means both are slower.
Less and hence
So
it should be
it should
lesser.
it should be faster. Star schema.
Hence smaller. Thanks. Then
Snowflake.
okay. And when it is relatively big in size, for example, if it just contains 8 or 10 records only, then it doesn't make sense. But if it contains millions of records, then it makes sense. Split it up.
So, which schema we should take actually? Star or Snowflake?
Basically, for example, if you have a customer table out there, there are let's say around 1,000 customers only, that is okay. Basically, you can go for star schema only. But if there are 1,000 or 1 million customers or 10 million customers, maybe think about it. And also, basically, what you can do is to check the query performance.
Yeah.
What is the kind of benefit you are getting?
It's because most of the time it's come to a query performance again.
Yes.
So,
We'll cover that. That's why I've added one point out there. If you see in the kind of topics that you'll be covering, that is how does it store like and how to improve the performance. Because once you start developing is okay, but when it comes to query performance, okay, at that time if it takes longer, the business side says it takes very less amount of time when I'm generating SSAS report, whereas it is taking longer time for you. So that is these are kind of things that we need to take care of. Okay, so how does it store like? And there are basically when this they started developing SQL Server analysis services, at that time they were calling it as Vertipack engine. Okay, and in Vertipack engine you can store in two ways. One is multi-dimensional ways, which is Qube, wherein you've got this dimension, this state, this region, and this product. What is the value like? Okay. The figures are the measures, date, region, product are dimensions. So, but internally it won't appear like this rows and columns. It has got its own internal structure. This is just for making clarity to you. That is, it is something like this. So, but there can be n number of dimensions. So that's why when you just drag the field at that time itself, it just shows you the data, because the data is already in computed shape. So you've got cubes are multi-dimensional. Dimensions provide the structure to the cubes. Measures provide data in the cube and come from fact tables of star schema, are aggregated at multiple levels along the dimension. When we say aggregated at multiple levels, what does it mean? Aggregation can be like count, sum, these kind of things, average. So it is already done in the computation. You just need to drag it and use it. So in real time, how does it work? Like developer station, here in the developer will do the deployment, and here the processing will happen out here. Relational database engine and data. First, the developer creates the analysis services database dimension that Qube using the bits in of there. It is called Business Intelligence Development Studio, or it is called as SQL Server Data Tools in SQL Server 2012 onwards. Okay, and the database project is deployed to analysis servers. Now this creates a structure out here, but how will the data come? It will come from relational engine. Okay, here in the processing will happen, your jobs will run, which will populate this particular database, the data warehouse. So this is, and also some of the times people ask, that is, we have got a datamart. What is a datamart? It's nothing. It's a piece of data warehouse where all the information related to specific business area is available.
Just one part.
For example, you got the production data mart, finance data part. Okay, and usually they do it. They will name it like all the finance data parts. They will start with the schema finance dot production dot HRD dot. Okay, this is how basically this is just to differentiate, because when you are doing the development, same table may be here in one data mart and in the other one as well. As an example, you can think of a company which has got different departments or distinct business areas with lots of data related to it. They are all related to the same company but divided by usability into several data marts. Advantages: segregation, easier access, faster response, simpler queries, and specific to user needs, easy to create and maintain. So that is the basics about data warehouse. Okay. Any question you have?